Hey, Jeremy. Thanks for joining me for Espresso 4.0.
Hi, my
Uh,
pleasure.
Always happy to have you here. I mean, it's nothing strange. It's just two colleagues having a warm beverage, right? With
Of
a little
course.
bit of a camera over there, but don't pay too much attention to it. Anyone you want to say hi to? I hear your mom is a huge
Yeah,
fan.
hi, Mom.
There we go. Hi, mom. And yeah, why don't we jump right into it? Hottest topic this time of year, or really in the past few years, in fact, is sustainability, right? I wanted to ask, in your opinion, what is, in particular in the manufacturing industry, what is the benefit of data when it comes to tackling some of sustainability problems?
Mhm. So sustainability is a big word, a big buzzword that is indeed quite often used these days.
Mhm.
And you have to know what is behind sustainability. So
Mhm.
for industry, what would it mean?
Yeah.
Sustainability is producing and emitting less CO2, maybe
Mhm.
in one sense. It also covers the fact that you can use the same material as input and optimize the throughput, or you can consume less of your consumables,
Mhm.
like fuel, water, gas, to still achieve the same production targets.
Gotcha.
So behind sustainability, we have these potential different silos where we can attack things. Currently, of course, it's everything about energy consumption because of the prices of all the energy stuff that we know.
Mhm. Mhm.
So
Nothing to kick us into more sustainable initiatives than rising prices of energy, right?
yeah, indeed, we have some others, and sometimes it's water, for example.
Mhm.
Water in some places is a kind of expensive resources,
Mhm.
not to get, but to find actually. In some remote place and plants, you need water to do random things, and it's difficult to have. So if you can maximize the usage of water,
Mhm.
it's also kind of more sustainable production that you can have.
Fair enough.
I had a good example of that. For example, 2 weeks ago, I was in a customer in mining area in Canada, and there water actually is not a problem
Mhm.
because it rains a lot. Water um, got impregnated in the ground,
Mhm.
and then they have these huge pits where they blast the rocks to get rocks to be processed and produce some specific products from that. And actually, there is so much water that the water infiltrates the ground and is pushed outside of the walls of the pit at high pressure. So you have kind of waterfalls coming from the walls of the pit. And actually, they can pump this water
You can use
and they
it.
recycle it to
Yeah.
use it in the production. And also, they have so much that they can vaporize the tracks where the trucks roll, so they don't produce too much dust for the neighborhood.
Ah, smart.
So in that case, they can use it because they have a lot. But in some other case, you can have no water at all, but you need some. So
Mhm.
there you need to optimize it.
Understood. And so, really, in conclusion, what you're trying to say is that data can help us in the usage, or rather, in reducing the amount of resources we use in the production, optimizing, making
Yeah.
it more efficient. And the big resource, of course, is energy, which comes in different forms.
Mhm.
How can data help us do that?
Yeah. So usually production processes are already quite well optimized because engineers know what they have to do to have a production that is under control, stable,
Mhm.
and that produce the best possible throughput.
Yeah.
So everything is quite well configured already.
Yeah.
Because they can see things, they have their empirical way of modeling everything that's happening with their own systems of
Mhm.
physical equations, thermodynamics. All of this is quite under control. What can happen is that you have some subtle variation in the process that can maybe not be captured by human eye or by classical mathematical modeling,
Mhm.
because it can be some things that happen maybe not all at the same time, subtle variations in different things, not really exactly matching at the same time, but the overall effect can impact your production and the material that is used.
When you say classical mathematical modeling, do you mean expert systems, or you're referring to expert systems?
Yeah, kind of expert system, or even really deterministic sets of equations.
Sorry, go on.
And then what we will be able to do a bit more, maybe with machine learning techniques or probabilistic approach, is to group all these small variations that cannot be captured by human eye or by these deterministic systems, and interpret these small variations and evaluate their effect on the production output.
Okay.
So what we would do for a project on energy optimization, for example, we would look at some period of time where we achieve good production with reduced energy consumption, for example. And we will try to use all the context data we can have from the machines and the production lines, or some other type of data like the ambient air temperature, the humidity. All these can have an impact. And we can, based on machine learning technique, extract these ranges of values, even if they are really subtle and difficult to catch. Potentially use them to find out that in this specific condition, you can use less energy and still achieve the same output.
Understood. In fact, what you mentioned is that manufacturing industry has got it. I mean, they've optimized things quite well up to a certain point. And there's a really small margin left that you can optimize. But given the fact that, steel industry is, I think, the third, fourth, one of the top 5 biggest users of energy in the world, like any percentage, maybe even half a percentage of efficiency, which can be hidden in their data, which can be logged rather through machine learning, can result in huge benefits, both for the environment as well as, reduction of costs. Having mentioned the steel industry, how can these types of solutions be implemented? Where exactly within the steel manufacturing process? And how would someone go about starting a project like that? What would they need?
Yeah, so first thing is to identify where you can have such savings. So everything that consumes, for example, gas or fuel can be targeted, like reheating furnace, annealing sections, all these things that actually consume a lot of heat. So for all of that, actually, you can find these different sources. You can check the data that you have in these systems. So do you have data about all the equipment itself, temperature measures, pressures, humidity, air environment, maybe vibrations, gas compositions, different things. The property of the material that is processed.
Of course.
Because based on the chemical composition of the steel, for example, you can have different treatment or different reactions to heating. And of course, you have to monitor the output of the production. Because if you produce some product at reduced energy, but the quality overall is not good, you don't want to learn from that.
Correct. You might have to rework it, which then you need to spend more energy and so on. Or you discard it, which is even worse.
Yeah. Sometimes it's even a full reprocess. So they have to scrap the material. They can recycle, but it means go again to blast furnace or electric furnace and redo the full loop, including all the steps that consume a lot of energy before.
Yeah. So what's important is that when you're looking into cases in data where you can save on energy, is that you always at all time also maintain adequate quality of the output. Otherwise, it makes no sense, of course, logic.
Yeah.
You mentioned what we need. How would they launch a project like that? Where do they start? Is there a pilot, feasibility assessment, anything so like that? Are there, is it a case-by-case scenario? Are there already prepackaged solutions?
So yeah, we can do some kind of feasibility assessment. So we have, if we have a data set with the 3 features that we mentioned before. So the process data, material data, and the output data. Probably we can find some already quick insights from the data with some prepackaged algorithm. So we have some kind of out-of-the-box tools that can more or less apply to every case,
Mhm.
but will give you a view of is it feasible and an idea of how much you can win if you apply this algorithm. And then if it's successful, we can go even more in details with more customized approach to be sure that we get every last, it's not percent, but tens of percents that we can find in this optimization.
Correct.
And every tens of percent, as you say, on large scale and on big consumption can have a huge impact.
Got it. All right. Well, thank you as always, Jeremy. Always a pleasure having you. I learn something new every time. Hope to have you soon again. And let's get back to work.
Yeah, my pleasure. See you soon.